Hello everyone, welcome to the fourth lecture of the Neural Networks from Scratch series. In this lecture, we will be implementing our first class in Python, which is the class for dense layer. This will be a transition point where we'll be actually coding using classes and instances in Python. Before we come to this point, I just would like to make a quick note on generating non-linear data. So up till now, all the data which we have looked at, we have just wrote down inputs like these from scratch. But if we want to feed in 50 or 100 data points, it becomes quite difficult to write this array every single time. So we are going to look at a simple function to generate the data. And the data which we'll be generating, the input data, will be non-linear. The reason we consider non-linear data is that if you look at linear data, which looks like this, and many things in our life, or I should say, few things in our life are linear, right? Uh, let's say the amount of food you eat every day, if you plot that, it will be a constant line, probably, or slightly increasing, slightly decreasing. So it might follow a linear tendency, or it will be constant. It will be a simple variation. So linear data is easy to model, but most of the things in real life which we see are complicated, such as weather. So the weather might follow an oscillating pattern like this. Mostly we deal with data which is not linear. And neural networks are designed to handle non-linear data. So it will be like we have a very powerful tool, but we are using it for linear data. That wouldn't make too much sense, because linear data and handling linear data is very easy for neural networks. Even a simple regression model can do this. The reason we are building neural networks from scratch is that we want them to deal with non-linear data. We want them to deal with tough data and to find patterns in that data. So in this series henceforth, this is the data which we'll be looking at. It's called as the spiral data, and the inputs have two components, x1 and x2, which have been plotted over here. So if you look at this plot on the left side, this is for x1 and this is for x2. If you plot x1 versus x2, it looks like in the shape of a spiral. So earlier, the examples which we took, every input had four data points, right? But now we are going to stick to every input which has two data points. So if there is one input being fed to the neural network, it will look something like this. If there is a second batch, we'll consider both. If there is a third batch, it will look like this. And the data points will be taken from this spiral data. We will also encode it right now with three categories. The red as the first category, which is the first spiral. If you trace it out, it will be a spiral. The green will be the second spiral, and the blue will be the third spiral. Eventually, we'll end up making a classifier which can detect these three colors and which can detect functions to separate these three colors. This is a tough problem, right? It's not a linear problem at all. For now, you don't need to worry about these colors, but later we'll be classifying this data into three sets and uncover which color corresponds to which data. For now, I just wanted to show you how the data points are generated. So to generate this data, we'll be looking at a Python, and we'll be using this package called nnfs, which is just used for generating data, and it has a further command called spiral data, which automatically generates this kind of a plot. So I'm going to be generating 100 samples, which means I'm going to generate 100 data points. And in this plot, I have plotted the x value versus the y value. So remember, each data point has two values, x and y. And here I'm just plotting x versus y. The spiral becomes really obvious when you plot the colors. So here you can see I have also given the number of classes to be 3. The first class is the blue class. You can clearly see it looks like a spiral. The second class is the green class. That also looks like a spiral. And the third class is the red one. Currently, the neural network is not aware of these differences because we have not encoded the data currently, saying that this belongs to the red class, this belongs to the green class, and this belongs to the blue class. Right now, the entire data is just one big data matrix for the neural network, which looks something like this. I just want you to take into account the shape of the input which is going to come to the neural network. So at each time point there are two inputs which are going to come to the neural network, so two inputs, and then those will be fed into the first hidden layer, etc. Okay, now let's move forward and let us implement our first class in Python, which is the dense layer class. Why do we need classes? It just becomes very easy to implement the Python functionality when we have multiple layers and a bunch of layers. It's not always easy to write statements like these if we want to feed the layer 1 output into the layer 2 output. We don't need to write the dot product every single time, right? There should be a global function which has written this dot product once, and then that needs to be called. So it's just very efficient to work in terms of classes. Now, I know that there are many students who get through a neural network course without ever understanding what is a class in Python, what is an instance, and what's a method. So these are all terminologies from object oriented programming, and students get through with the Python course or the neural network course without understanding ever what these mean. However, I have found that if you have a basic understanding of what each of these terminologies mean, then you are not scared of Python code, and it just becomes easier to understand the different aspects of the code. So, I am going to explain to you what these things mean. So, first, let me explain to you what a class means. So, when you create a class in Python, it's like creating a blueprint. So, here I have created a class called dog. Okay, and when you create a class, remember that you can give methods in the class which are functions. So this init with two underscores here, underscore init underscore, this shows up in every single Python code. So remember that this is a special function. It's a special method which is automatically called when an instance of this class is created. I'll come to what an instance is, but right now remember that init is a special function which is by default called when you create an instance of this class. You don't need to specify that I want to call this function, it is called automatically. Now, what do you mean instance, you might say? So, essentially, when we create a blueprint, which is the class, we need to create objects in that blueprint, right? I have created a blueprint for a dog, but I want to now create an object like a particular specific dog whose name is Buddy and whose age is 3. So, the way I do it is first inside this init method, I write three things: there is self, there is name, and there is age. So, name and age are the attributes of the particular dog, and self is used to refer to that particular instance. So, let's say when I call this function, my dog is dog, buddy, and 3. So, when we write something like this, it means that we have created one instance of the dog class, or we have created a specific object of a particular dog, and it has two attributes: buddy, which is the name, and age, which is 3. So what happens internally when we write this is that this init function will be called by default. So whenever you execute this statement, the init function will be called by default. And what this function does is that when you do self.name, it means that it is used to access the particular instance which has been created. So now I am creating this instance for this dog named Buddy, right? So self.name will be name, which is Buddy, which has been passed, and self.age is age, which is the number 3 which has been passed. And henceforth, when you write different functions within this class, you can always use self.name and self.age now, which will refer to this particular instance. So whenever you use self.name in any other method, it will know that it is Buddy. Whenever you use self.age, it will know that it is 3. The reason we use this self here is that we need that script to know that this is the name of the particular instance which has been created. Now, let's say if you create another instance called your dog, whose name is Lucy and whose age is 5, then another instance or another object will be created. Whenever this command is run, again the init function is invoked. Then self.name will be Lucy and self.age will be 4. So when I used to look at neural network code, I did not understand what this self means. So just remember that it is used to access the specific instance which has been created. And what is an instance? Instant is just basically calling a class with the specific attributes. So this is the first instance, my dog. Your dog is the second instance, let's say. And what this init does is that it's a special method which is automatically called by Python when that particular instance is created, and it assigns value to the instance attributes. So self.name is the name attribute of this instant, and self.age is the age attribute, and it assigns value. So self.name will be Buddy in the first instance, self.name will be Lucy in the second instance, self.age will be 3 in the first instance, and self.age will be 4 in the second instance. So remember to keep these concepts in mind because this will show up everywhere when you look at Python and when you look at different classes. If you have not learned C or C++ before, it's no problem. You just need to understand the basics of what is a class, what is an instance. Also remember that sometimes instance and object are used interchangeably. So this terminologies might be a bit confusing at the start. Now what we'll be doing is that we want to create a dense layer class. So this is our objective. We want to create a dense layer class, and what this class should do is that, so remember every class should serve a function. What this class should do is that, let's say these are my inputs, which are two inputs, x1 and x2, and this is my first layer, right? So I have three neurons here. So number of neurons is 3 and number of inputs is 2. What I want to now do is I want to create a class which, given the number of neurons in the layer and given the number of inputs, it should predict the output. And the way it will do that is that this class should also randomly assign the weights. So each neuron will have two weights and one bias feeding into it. So this class should randomly assign weights to every single neuron here, and the class should randomly assign a bias to every neuron, and then it should predict an output. By the way, we have already seen how the output will be predicted, right? Just remember np dot dot uh, np dot dot x comma w transpose. Remember this. This is used everywhere. Np dot dot x comma w transpose. So we want to do this, and the output will be predicted by np dot dot x comma w transpose plus beta, which is the bias term. Now, from henceforth, I am going to introduce one more convention. Up till now, when we looked at the W matrix, it was written something like this. So, these were the weights corresponding to first neuron. These were the weights corresponding to the second neuron, and these were the weights corresponding to the third neuron, right? So the dimensions were basically the number of rows were the number of neurons and the number of columns were the number of inputs. And we always have to take this transpose. So then to avoid this unnecessary transpose, every time when we represent W now, I'm going to change the convention and we are going to represent it as inputs and neurons. So basically when you look at one neuron, its weights will be now in the column instead of the weights of one neuron being in the row. So the first column are the weights of the first neuron, the second column are the weights of the second neuron, and the third column are the weights of the third neuron. So now this formula will change to just np dot dot x comma w plus b. That's it. We don't need to take the transpose every single time. So I want to implement a dense layer class which does this. It should just take the neurons and inputs, neurons and the number of inputs as is two inputs. It should randomly assign weights and it should produce an output according to this formula. So let's see how to do that. First, let us name our class the layer under scroll dense. And I'm going to implement two methods in this class. The first is of course the init, which will be automatically called when this layer or an instance of this class is created. And what will this init function do? it will take two inputs, the number of inputs to that layer and the number of neurons. So in this case, the number of inputs will be 2 and the number of neurons will be 3. And then what this layer should do is that it should initialize the weights and biases. That's the function of this init function in this class, or that's the role of the init method in this class. It should take the number of inputs and number of neurons and construct the weight matrix and the bias matrix. So the way it will do this is that first it will notice the dimensions will be, the number of rows will be the number of inputs, number of columns will be number of neurons, and then it has to assign a random value to each row and each column, and the bias matrix will be this based on number of neurons. Now, to initialize the weights, we are going to use a function called randn, which is from a package np.random. So what this will do is that it will sample outputs from a random or a Gaussian distribution like this. So this is a Gaussian distribution with mean 0 and a standard deviation of 1. So what this will do, look at this command np.random.randn, and it will take inputs and the neurons. So it will first of all match whatever is given here. So it will know that it has to create a matrix of inputs into neurons, which is exactly what we want it to do. And then for every single value here, it will assign values which have been randomly chosen from this Gaussian distribution. So maybe a value here, maybe a value here. It will sample more values from the mean. This is how it will do the sampling. Remember, we are assigning weights randomly at the moment. And the reason we are only taking from -1 to 1 is that we don't want the weights to be initialized by too high a value. In fact, we'll multiply this by 0.01 in the code so that the weights are even initialized to a lower value to prevent weights from becoming very large. So this is the main function of the init method. We'll initialize the weights. The weights will be initialized from a Gaussian distribution, and in the code we will write np.random.randn and inputs comma neurons. The reason we are not doing neurons comma inputs is that this is the convention which we are going to use for weights. So that we will just use np.x comma w when we take the dot product and add the bias. What this forward function will do is that it will do exactly this. It will do np dot x comma w plus b. So basically it will take the weights and the biases which have been initialized from the init method, and then it will return an output like this. That's it. So the advantage of this is that every time you create a new layer, you can just create an instance. So let's say I want to create a layer dense. I want to create a layer which has three inputs and three neurons. I just create an instance like this. If I want to create another layer, I just create an instance like this. And then all you need to do is that if you want to do a forward pass, you can just call this function dot forward. That's it, and it will return the output. If you want to find the output of this layer, you can just call the forward function and it will return the output of this layer. So every time you don't need to write dot products, you just need to write it once in this forward function. So this is how we'll be implementing this class. Now let us go to the code to see how this class is implemented. So this is the dense layer class as we start here. And as I mentioned, this class will have two methods, the init and the forward. Remember, the init has these two underscore signs because it's a special method which needs to be called whenever an instance of this class is created. And it will have two inputs, the number of inputs to that layer and the number of neurons. And as I mentioned, we will sample the weights from a Gaussian distribution whose dimensions will be number of inputs and number of neurons, and the biases initially will be 0. We can play around with this and even initialize biases to some random small values, but in this case for the spiral data the zeros values work. Then we will be defining the forward pass, and as I told you, we won't be doing the transpose since the weight matrix which we are generating is anyway inputs into neurons and not neurons into inputs. All we need to do is just take a dot product between x and w. So this is exactly what is done here. In the forward function, it will just take the inputs, and essentially those will be the inputs into the layer, and then it will take a dot product between inputs and the weights, and then add the biases. That's it. So that will be the output. Now you can see how it is generated for the spiral class. So what is exactly happening here is that I have the spiral data like this, two inputs, but I will have a batch. So two inputs, two inputs, two inputs, and I have a batch of 100 measurements. So this will actually be so this will be 100 and this will be 2, and then this is going to be fed into my network, which initially has 3 neurons, and I want an output from here. Okay, so let's see how the layer dense class is called in this particular case. First, we have the data, and we have 100 samples. So the data will have a shape of something like this. It will have 100 rows and it will have two columns. But we are now equipped to deal with batch data. Then we call the layer dense. We create an instance, 2 and 3, which means the number of inputs will be 2 and number of neurons will be 3, exactly like we want. 2 inputs and 3 neurons. And so when this instance is created, already the weight matrices and the bias matrix will be created. So the weight matrix will be inputs into neurons. So remember, the inputs are 2 and neurons are 3. So it will be 2 rows and 3 columns. So it will be something like W11, W uh, 12 first neuron weights, W21, W22 second neuron weights, W31, W32. These weight matrix will be created. The bias matrix will be created like this: B1, B2, and B3 when the first instance is called. Then when we call dense one dot forward x, what this will do is that it will call the forward pass. So what that will do is just do x dot w plus b, and then we will have outputs. So essentially for every single input we will have three outputs. uh, so and there are 100 such inputs, right? So then the size of this will be 100 rows and 3 columns. That will be the output. So we now have to just call two methods. First, the layer dense, which is the initialization of weights, and then the forward, which is the output of the first layer. And here we can just plot the first 5 entries of the output. So the output has 100 rows, right? What we are doing in the code is just plotting the first 5 rows. So here we are plotting the first 5 rows, and every row represents the output of the three neurons. So if you look at the second row, it represents the second batch of data. This is the output from the first neuron. This is the output from the second neuron, and this is the output from the third neuron. So this is the advantage of implementing a class in Python. Whereas if you had not implemented the class, you will need to write the np function every single time. Once you understand a class and how to write methods within a class, it actually becomes quite easy to understand Python codes. But remember the basics which we saw in today's class. What is a class? What is an instance? And what is a method? Why is this self used? Remember, self is used to access instance or the specific instance. Also remember that underscore underscore init underscore underscore is a special method automatically called by Python when when that instance is created. Initially, when I learned these codes, I did not understand why these two underscores are used, but now I have a much better understanding. And similarly, I showed you right now how to create the layer dense class. If you have an understanding of matrices, right, like the dimensions here, it becomes very easy to understand why here, if you look at the code, why n inputs and n neurons is written, and what if it's written the other way around? If it's written the other way around, then we would have had to use a transpose over here. And you will understand this if you write things from scratch, like what I did. Okay, in the next lectures, we'll be looking at activation functions, which we have not covered so far. And then after that, there are a number of interesting things planned for calculating the loss function, etc. So, thank you so much, everyone, for sticking with this series till 4 lectures, and I'll see you in the next lecture.